All right, so here are our last couple examples. And so same thing, when to solve each equation. We're not doing inequalities with our lesson. We're just going to stick with equations. But similar things, right? The only thing with the inequalities, if you ever see them on a standardized test or something, it's the same thing to solve. It's just that if you multiply or divide by a negative on both sides of the equation, then you flip the inequality backwards, right? So that's the main difference in terms of at least the mechanics of solving. All right, and definitely want to check our solutions because we have variables in the denominator, so we want to make sure that we don't have any extraneous solutions. Okay. All right, and if we do, we want to make sure that we eliminate them. All right, so number 7. So here I have a bunch of stuff going on in the denominator. And so first thing I want to do is factor any polynomials that we can factor. So this can't factor, not a difference of squares, not a difference or sum of cubes. Same thing with y minus 5. So now we'll go to this one. This is a simple quadratic, so we're going to get y. We're looking for numbers that have a product of 10 and a sum of 3. So that's 5 and 2. Okay, and then this tells us the sign of the bigger number, so 5 is going to be negative. And then this tells us the signs are different since that's negative. So that means the 2 will be positive, different. And that's usually, a lot of times that'll happen. Notice how it's the same two values there. So usually these will kind of give you hints as to what your factored polynomial may be. All right, so now my LCD, okay, I need one of these, right? So I'm going to get a y plus 2. And I'm going to need one of these, so I'm going to get a y minus 5. And then when I look here, those are already represented, right? I already have a y minus 5 and I already have a y plus 2. So that means we have everything we need, right? We don't need an extra one of these. That would be excess, right? That would be excessive or wasteful. So I just so I can go with just these. So now what I'm going to do is I'm going to multiply each term by the LCD. Okay, so it's going to be y plus 5, y minus 2 here, y plus 5, y minus 2 here, and y plus 5, y minus 2 here. Okay, so what will happen here is these will, oh, I messed up here. This will be y minus 5 and y plus 2. Sorry about that. All right. And so, so anyway, what will happen here is the y plus 2's will cancel out. And so what I'll end up with is y times y minus 5. And you could distribute those. You could skip this step that I'm writing here, but since there's a lot going on, just want to make sure that I'm showing all the steps. So here, y minus 5's will cancel out. So I have 7 times y plus 2. And then here, the y minus 5 will cancel out, and the y plus 2 cancels out, right? And remember, this has already gone away because I factored it. And so all I have left over there is just the 14. All right, so we went from a bunch of fractions that may have been a little spooky, right, to now down to, basically a linear equation that's pretty straightforward. Okay, been there, done that, right? So we're going to distribute here. So we'll get y squared, actually quadratic equation, huh? So y squared minus 5y. Then here we'll get 7y plus 14 equals 14. So we can combine like terms here. And while I'm at it, since I just have a constant over there, I'm just going to subtract it from both sides. So actually, we end up with y squared plus 2y equals 0, right? And so now we can factor here. This is a binomial. It's not a difference of squares, but we do have a GCF there, right? So we can factor out a y. And then we get y plus 2 equals 0. Y times y plus 2 equals 0. So our two possible answers are y equals 0 and y equals negative 2. Okay. Now if we plug in 0, there's no problem. 0 plus 2 is 2, so that's okay. 0 minus 5 is negative 5, so that's okay. Here the same things, we're not going to get 0 because we just, we'll get those values that we just talked about. So 0 is a valid solution. Okay. Negative 2, on the other hand, if I plug negative 2 in right here, negative 2 plus 2 is 0. So that is an extraneous solution. Okay, so even though we got two solutions algebraically, only one of them works in actuality. Okay. All right, let's take a look at number 8 now. So number 8, there's nothing I can factor in the denominators, right? I don't have any, it's not a difference of squares, it's not any type of simple or complex quadratic or anything like that. Same thing with a plus 5. So yeah, we're just stuck with those. That's okay. So our LCD is going to be just those put together, right? 2a plus 7, we need that. And then we'll grab an a plus 5 as well. So that's our LCD. So we're going to multiply each term by the LCD. So 2a plus 7, a plus 5 will multiply by 3. We'll do it here. 2a plus 7, a plus 5. And then we'll do the same thing here. 2a plus 7, a plus 5. Okay, remember I'm just multiplying it to the numerator. So if you want to think of it as a fraction, you can think of it as over 1. Okay. And so what will happen is with the 3, nothing cancels out. So it'll just be 3 times 2a plus 7, a plus 5 equals, don't forget the equal sign, that's really important. Here, these cancel out, so I'm just going to have 6a minus 1 times a plus 5, right? So I just have this left times this. Don't forget the parentheses, so we're going to actually have to FOIL there. And then plus, here the a plus 5s cancel out, so I'm just going to have 22 remaining on top, multiplied by 2a plus 7. Okay, so now we just have some work to do here. We have some foiling, so I'm going to do that just right here. So I'm going to put 2a times a is 2a squared, 2a times 5 is 10a, 7 times a is 7a, and 7 times 5 is 35. Okay, so I'm just going to combine like terms real quickly, and then we can multiply by 3. So it'll be 2a squared plus 17a plus 35. And we'll multiply 3 by that. And I'm just kind of doing all this so I don't have to rewrite all this other stuff again. So distribute the 3. So we'll get 6a squared plus 51a plus 105. Okay, so that's what we get on the left. So now on the right, we can just bring these down, right? So we can just distribute and bring them down here, and then we can simplify all at once. So 6a times a is 6a squared. 6a times 5 is 30a. Negative 1 times a is negative a. And negative 1 times 5 is negative 5. And last but not least, we're going to distribute the 22. So we get 22 times 2a is 44a. 22 times 7 is 154. All right, so now we can combine like terms here on the right. So I have 30a minus a plus 44a. So that's going to be 74a minus 1 is going to be 73a. So I'm going to bring down 6a squared. No like terms there. So this will be 73a. And then I'm going to combine negative 5 with 154. So that's going to be positive 149. Okay, so now we're going to get everything on one side because we have a quadratic. And actually, real quickly, notice that 6a squared and 6a squared are the same. So we can actually just cancel those out. If we subtract 6a squared from both sides, those cancel out. So actually, this turns out to be just a linear equation. So now we want to get our a's on one side, numbers on the other. So since 73a is bigger, I'm just going to subtract 51a from both sides. So I can put my a's together. And then while I'm at it, since I got my a's on the right, I'm going to subtract my numbers from that side to get my numbers on the left. And so we'll end up with negative 44 equals 22a, right? And then we divide both sides by 22. And we get a equals negative 2. All right, now we just want to check that. So if I plug in negative 2 here, 2 times negative 2 is negative 4, plus 7 is not 0, right? It doesn't really matter what it is as long as it's not 0. And negative 2 plus 5 is 3, so that's not 0. And so we're in good shape. All right, so that's how we solve rational equations, is we factor the denominators if necessary, find the LCD, multiply everything by the LCD. That'll get rid of your fractions. Sometimes it'll leave kind of a big mess that you have to, operate with and work out, simplify. And then once you figure out what kind of equation it is, if it's linear, get the variable by itself, and you're basically done. If it's quadratic, you want to set one side equal to 0, and if you need to factor, use the quadratic formula, things like that from there. But either way, make sure you check for extraneous solutions, right? Check to see if your answers produce zeros in the denominator in the original. If it does, cross it out and just go with the other ones that do work. And if there's no extraneous solutions, that's fine too. Just box up your answers, okay?